Hey everyone, in this Back to the Basics tutorial, we're going to see how to use objects in C++. So we're going to see how to create a class and then instantiate that class as an object to be used throughout our application. So again, this is a Back to the Basics tutorial, so this is just very basic fundamentals for programming. It's useful if you're getting started with programming or you're taking a introduction to computer science type course. Seeing these examples will help you because they offer a lot of repetition, and that's something that you need when you're just starting out. So you'll notice that I do have my project open. I am using Visual Studio Code. In a previous video, I did demonstrate how to configure Visual Studio Code to develop C++ applications. If you're curious, go ahead and find that video on YouTube. Otherwise, let's just go ahead and assume that you've got an appropriate development environment. And I do have other tutorials that I've made as far as Back to the Basics, so if anything doesn't make sense that I show in this particular tutorial, go ahead and search for others on the topic. So I do have my basic example. What we're going to do is we're going to create a class, so that way we can instantiate it as numerous objects. And the reason why we might want to do that is because we want to reuse a common data type that is a little more complex than just a primitive like an integer. So for example, let's say, I know that you probably hear a lot like the cars example or the person example where every car has a name or a color and things like that. We're going to change it up. We're going to use Pokemon as our example, which is going to be very similar to the other examples. But then after that, we're going to change it up and try to do something a little more complex. So you'll notice that I do have, what I'm going to do is I'm going to say the following. I'm going to say class, and I'm going to give it a class name. So I'm going to call it Pokemon. So that's going to be how we instantiate this particular object or this particular class. Inside of our class, we have the option to choose private, public, and protected variables and methods. We're going to be focusing on private and public, but what we're going to do is we're going to create a few variables that represent what our Pokemon can consist of, and then we're going to create a few methods for setting those variables. So let's go ahead and create some private variables. And our first private variable is probably going to be a Pokemon ID. We're going to have maybe a Pokemon name and then maybe a Pokemon type. And if you want to get into the finer details of things, Pokemon generally have more than one type. But for this example, we're going to have Pokemon only having one type at a time. All right, so we have our private variables. Let's go ahead and now create some public variables. So what I'm going to do is I'm going to say the following. I'm going to say public. And they're actually not going to be variables. I'm actually going to create public methods. So starting with a constructor method, I'm actually going to say Pokemon. So the constructor method is how we can actually set these private variables or do anything for that matter as the class is instantiated. And then we'll be able to access any other method as we go along. But let's go ahead and say Pokemon is going to be our constructor method. And Pokemon accepts an ID and it accepts a name. So we're going to set the name and the ID variables. And you'll notice that this is a constructor because I named the method the same as the class on line 7. So inside of this, I'm going to say this, and then I'm going to use the arrows because I'm going to point to our class member variables. But I'm going to say that the class variable for that particular instance, so the ID variable, is going to be set to the local variable. The local variable being what we pass in to the constructor method. And I'm going to do the same thing for the other as well. So I'm going to say this, and then I'm going to say name, and I'm going to say name like this. Now, this is where things get a little different. So I'm going to set the type as well. So the type in this case, I'm going to say this type. And because we didn't pass it in, I'm going to set it as unknown. So I'm just going to name it as something. I'm not going to leave it as an empty string. So let's see why this is erroring out on us. So public, private, everything looks all right. So it's actually failing because I have brackets here. You shouldn't have parentheses when you're defining your class. So that made my errors go away. So going back into what we had, I have my public constructor method, and we have unknown as the type. This gives us an opportunity to expand on our constructor method. So we actually can now do an overloaded constructor method. So this would be an alternative method. And you'll see where this is valuable when we start using this particular class as objects. But I'm going to create another constructor method. It's going to have the same name of Pokemon. It's going to have an ID. It's going to have a string for a name, but now it's going to have a third argument, so a third parameter, and this one's going to be a type, so string type. So this time we're giving the user the option to now manually set that type. So I'm going to say I'm just going to copy everything from line 17 through 20. I'm going to paste it in, but this time I'm going to set the member variable for this particular object to the local variable, which would be type. Just like that. So let's see where we end up with first. So let's go back into our main function. We're gonna now instantiate this class. So we're gonna do it twice. So we're gonna see both variations. So the first time we're gonna say Pokemon because that's what our class is called, and I'm gonna give it a name. I'm gonna give it a name for this particular object. I'm gonna call it Pikachu, and I'm gonna say equals Pokemon, and the ID for Pokemon is gonna be 25. And the name is just going to be Pikachu. Now I'm gonna make another Pokemon because this is where it becomes valuable to use custom objects inside of your application because we can reuse them over and over and over again for new instances. So we're gonna say Pokemon, and I'm gonna say Bulbasaur, and that's gonna be Pokemon. It's gonna be Pokemon 1. I'm gonna say Bulbasaur. And I believe this Pokemon is a grass type. We know that Pikachu is electric, but we're not going to add anything as of now. So I'm going to save it. So it doesn't really do anything beyond this. If I were to run it, nothing would happen. But it is in fact creating two different instances of this Pokemon class. So let's kind of expand upon things now. And I'm going to explain more as we go along. But let's say, maybe we want to print out what each of these variables contain. So we won't get into anything too complex yet, but let's go ahead and create a print method. So this is not a constructor method. So I'm going to create a method called print, and it's going to have a return type of void. So it's not going to return anything. And what this is going to do is it's just going to do a simple cout. So I'm going to say cout, and I'm going to say this ID because I want the member variable for the particular instance that's being used. I'm going to separate it by a colon. So the ID is just going to be the Pokemon ID. I'm going to print out the name. And then I'm also going to take it a step further. I'm going to just fancy it up just slightly. I'm going to print out the type. So this type. And we're going to call it a day at that. And I'm going to do endl. So now if I wanted to, I now have the ability to call a print method on each one of these objects. So for example, let's say Pikachu, and I'm going to say dot print. And I'm saying dot instead of using the arrow because we're not referencing a member variable this time. We're just calling a function from within this particular class, so this object. So I'm going to say print. I'm also going to say Bulbasaur dot print, and we should have two different print lines when we run it. So I'm going to say terminal, and I'm going to say run task, and you can see in my console here that it printed out as expected. So it printed out Pikachu. We didn't set the type, but we did set the type for Bulbasaur. So it's really fancy in that sense. So let's go ahead and expand upon things. So we didn't set a type for Pikachu when we instantiated the object. So let's go ahead and add a method that'll allow us to set it after the fact. And we can add it anywhere. We can add it above, below, but we're just going to add it below the print. We're going to say void, so there's going to be no return type. We're going to say set type. It's going to be string type, and it doesn't really matter what you have as the parameter name, but it's best to name it to what you're trying to accomplish. So in this case, we're going to be setting the type. So that's why we named it as such. So we're going to say this arrow type. So this member variable equals the local variable of type. So the local variable of the particular function. So if I wanted to, now let's go ahead and try to call it on Pikachu. So I'm going to say Pikachu dot set type, and I'm going to say electric. And I'm going to take it a step further. I'm also going to say Bulbasaur dot set type, and I think, don't quote me on this, I think Bulbasaur is also a poison type. But let's go ahead and set it at that anyways, even if it's not. So in theory, it's going to set the type for Pikachu, and it's also going to change the type for Bulbasaur. So let's go ahead and try to run it. I'm going to say run task. I'm going to say run. And this time around, it says Pikachu is now electric and Bulbasaur is now poison. So we were able to add that particular method. And this is typically called a setter. So typically inside of your classes, you're going to have getter and setter methods. So the setters will set any of your private variables, and getters will get any of your private variables. So let's go ahead and create a getter. So we're going to say, this time it's not void, it's going to be string, because we're going to return a string. We're going to say get type, and it's not going to have any kind of parameters. But what we're going to say is we're going to say return, and we're going to say this type. So this member variable's type. And let's try it. Let's go ahead and say I'm going to add a cout, and I'm going to say Pikachu dot get type, and it's just going to get it for Pikachu. And I'm going to run it. So let's see what we get when we run it. So it's still printed out the first two because of our print statements from our print methods, but it also got the type and printed that out as well for Pikachu. So that's a getter. And typically you have the getters and setters, like, I mean, technically you could have these variables as public variables and you could set them and get them directly, but it's always good practice to make them private, so make sure that they are protected within your class, and then just access them strictly through methods. So it's good practice, but you don't have to. So we have those two. Let's kind of expand upon it. So typically, I mean, it's kind of boring just to say set type, get type, and print. You might have actual methods that do stuff within your class that actually are important. So let's go ahead and add another method. This will be a function. What we're going to do is we're going to get the weakness of a particular Pokemon. So we're going to do a conditional statement. So we're going to say string. It's going to return a string value of our weakness. We're going to say get weakness. And we're going to first do a check. So we're going to say string weakness. So this is a local variable. Unknown. So if the weakness is unknown, it's going to say so. But if this type equals electric, then what we're going to do is we're going to say, you know what, the weakness is ground or rock. So we're going to say weakness equals ground. Else if this type equals, and I'm just going to say poison, or we could actually just say grass. I'm going to change it back to grass. So if the type is grass, then the weakness is going to be fire. And we can go on and on and on, and so on and so forth, but we're just going to leave it at that for now. Keep it simple. And we're going to return the weakness. So we're doing a comparison against whatever the type is for this particular class, this instantiated object. So let's go ahead and try it. First, let's go ahead and remove this line that says Bulbasaur is now poison. We'll change him back to grass. And we're going to say, let's clone this line. We're going to say Bulbasaur. And we're going to say get weakness. So it'll still print out Pikachu's type, which is electric. I guess we could have left it as Pikachu, but it'll get Bulbasaur's weakness as well. So let's go ahead and try to run it. So it printed out that Bulbasaur's weakness is fire. So that's exactly what it should be. So we could have very complex functions in here. So that's kind of the gist of classes and objects in C++. This is kind of what makes it an object-oriented programming language. And the whole concepts, they carry over well beyond C++. So no matter what programming technology you're trying to use, well, I guess as long as it's an object-oriented programming language, you'll see classes and you'll be able to create your own. So let's try to use another example. I'm going to wipe this out. If you need to go back, I suggest you rewind your video. We're just going to see another example, so that way maybe it sticks in your head. So let's go ahead and start. Actually, I'll leave that. We'll just expand upon it. We're just going to create another class. So we're going to ignore the Pokemon class going forward. We're going to create another class, and we're going to call it person. I'm going to put my own spin on the person. So I'm going to say person. We're going to have a private variable, or a set of private variables here. We're going to have a name. And we're going to have maybe a savings. So we're going to say, let's call this, maybe let's make it a double. We'll call it savings. And we're basically going to check to see what this person's savings is, and then maybe what their savings will be given an interest rate in the future. So we're going to say public. We're going to have a constructor method for person. And we're going to say that there's going to be a name that can be passed. We're going to be able to pass in their initial savings. And we're going to leave it at that. So we're going to say this, and we're going to point at the member variable for name equals name. We're going to say savings equals savings for the local variable. And that brings us to now, and I need a semicolon at the end of my class here. But now let's add a function. Let's calculate the compound interest, or whatever the compound value would be after X amount of time. So this is another calculation, but let's say, let's call this double. We'll say get retirement. And what we're going to do is we're going to pass in an interest rate. So we're going to say, let's say double. We're going to say, let's say rate. And we won't allow them to add more money. We're just going to calculate the interest rate and the savings without adding anything, because I'm no math wizard. If I start doing math, probably 100% of it's going to be wrong. So let's go ahead and check the following. So you'll notice at the top I did include math.h, because I believe that there is a function that'll help us along. And again, if I'm wrong on any of this, I apologize. The point of this is not to show off math skills and try to teach you math. It's to try to teach you that, hey, it's very easy to create classes for your applications, so that way you can create objects out of them. But what we're going to do is we're going to say double retirement, and we're going to say we can just leave it at that for now. Actually, let's go ahead and say retirement equals, we're going to say this savings, and I believe what we're going to do is we're going to do times, and we're going to do POW. We want to do 1 plus the interest rate, which would be maybe rate over 100. And let's see what else we got. And the power value would be the amount of years. So let's go ahead and say the years, and we're just going to allow this to be passed in as well. So we don't have any errors, so that's probably a good sign. So actually, instead of just, what we could do is we can say return retirement, but actually we can actually probably do this. Return this dot savings, so on and so forth. So let's give it a try. So I'm going to say person. Let's call it nraboy equals person. I'm going to say Nick. And I'm going to say this is a total fictional value here. I'm going to say 10,000. Actually, let's go ahead and say 1,200. What I'm going to do is I'm going to say cout, and I'm going to say nraboy.get retirement. The interest rate, let's go ahead and say, is maybe 5.4%. And I'm going to say I want to see over the span of 2 years. So we'll say end-L. And then maybe if we're lucky, it will print out the right values. So we're going to say run task, run. So that $1,200 over the span of 2 years at that interest rate, that seems plausible. So it might be right. But you'll see now that inside of my main function, I now have a Pokemon object that I'm using, as well as a person object. So I've created 2 different objects here, and I'm using them. And I'm using them with their own member functions as well. So I do have my person, And I'll see if I can close this terminal, make it easier to see. But I have my person as well as I have my Pokemon. And the gist of it is it's more or less the same. So let's go ahead and do another overloaded function. So just like I can overload constructor functions, I can also do the same for others. So let's go ahead and say, I'm going to say double get retirement. And this time I'm going to not specify a, let's say I'm not going to specify years. So I'm going to say double rate. This probably won't make a whole lot of sense as far as from a plausibility standpoint, but at least it'll demonstrate what we're after. But I'm going to say return, and I'm going to say this savings times POW. I'm going to say 1 plus, and let's just go ahead and say the interest rate is 8%. And I'll say 8%, and I'll say it's divided by 100 because we got to convert percents into the correct decimal value. And actually, I did provide the rate. I take that back. So I provided the rate, but not the years. So the years, I'm just going to say 5 years. So I'm going to save it, and I'm going to do another one, and I'm going to say cout nraboy.get retirement. And I'm going to say this time I'm just going to specify the interest rate and nothing more. Whoops. So you'll see that I have now 2 different versions of this get retirement for the same person. So I'm using an overloaded method. So I'm going to run it. And you'll see, hopefully, maybe that's accurate. So over the span of 5 years at an interest rate of 8%, maybe it'll turn into that, hopefully. But at least you get the idea of overloaded methods. They're not just for constructors. And you could have as many overloaded methods as you want. Hopefully they're actually meaningful, but that's totally up to you. So it's very, very cool stuff. And you could do very powerful things by creating your own classes with their own functions. And there's actually more to it. We're going to see more in another Back to the Basics tutorial when it comes to inheritance of your objects.